generator. Right? Now if it's a generator, then the group is cyclic. Okay? So we have C4, C for a cyclic group. So this would be 3. So C4, you'd have, well, in this case P is not a prime, it's 4. Okay? So C4, so you'd have 1A, A squared, A cubed. That would be your group. So that's one possibility. Right? So your generator is little g, and g to the 4th is E. So that's one group type of G4, right? Just the cyclic group. And in general, that's true of any integer. You'll always, like you choose an integer n, there will always be a group of order n, and that's the cyclic group. Now there may be others. Now if n is prime, there are no others. But in general, for general integer, for n, general case, there will always be at least one group of that order, and that's the cyclic group, Cn. Right? Okay, so let's take the other case, 2, when G, this arbitrary element of G4 is now of order 2. Okay. Now let's take the case where all the elements are of order 2, except the unit. Of course, that's always the exception. Every group has just one element of order 1, and that's the unit. So except for the unit, let's assume all the other elements, all 3 of them, because we're talking G4, 4 elements, right? So let's assume the other 3 are all of order 2. Okay? So let's assume they all have order 2. Alright? So we take, just take 2 elements of this G, G4, and we've assumed they both have all three elements except for the unit. All of them have order 2. So if we just take 2 of them, they will both have order 2. Therefore, A squared is the same as B squared as E, right? And let's assume these are distinct, different elements. So in other words, A is not equal to B, and it's not equal to E, right? Because they have order 2, can't be equal to E, because then its order would be 1. Okay, well, so we assume A is not equal to B and A is not equal to E. And similarly, B is not equal to A and B is not equal to E. So these 3, A, B and E, are 3 distinct elements, right? So now we're trying to find the group. And if you know the group table, if you know a group's table, you know everything about the group, right? So let's try to find what particular elements are in the group. Let's try to calculate what the entries are in the group table. So now if A and B belong to the group, then because it's a group, it's closed. So AB will be a member of this group. But what's it equal to? Like if you have, like, here's your group table, here's A and here's B, and here's sort of A, well, here, in this form. Say you had A here and B here. So in the group table here, you would have AB, and we're trying to find what AB is equal to. We don't know yet. So AB is question mark, right? Well, we have various possibilities, right? Because of closure, AB has to be one of the 4 members of this group. We've assumed it's of order 4, so there are 4 members. Well, we can eliminate systematically various possibilities. So let's say AB is E. That's one of the 4 possibilities. Well, if that's true, then A is equal to B inverse, but B inverse is B because of this, right? The order of B is 2. So therefore A equals B. But we assumed they were different, so that's out. So AB cannot be equal to E, right? Contradiction. All right. Well, let's do the next one. Say AB equals A. well, that implies that B is E, but that that goes against what we assumed here, right? So that's out. So I'm putting an X here across, meaning eliminated, not not valid. All right. Well, let's do the next one. Let's assume that AB equals B. So that implies that A equals E, but that's out because we assumed A and B are non-unit. So that's out. All right. So AB is not equal to A. It's not equal to B. It's not equal to E. So there must be some fourth element, right? So this is not equal to these three. There are only four elements. So whatever this is, it has to be that fourth element, right? Because there are only four elements in this group. All right. So AB must be this fourth element. So you can add it in. And you can show, is that true? AB equals BA. I didn't see that. Is that obvious? Is AB equal to BA? Well, I'll assume it is. Okay. Anyway, so here's your group, right? So this must be one of the terms, and so is AB equal to BA? Given that A and B are both. Oh yes, I remember a theorem saying that if all elements are of order 2, except the unit, of course, in a group, then it's cyclic. Yeah, remember that as a theorem, right? So AB equals BA. So you can rewrite, and that's your fourth element, and so you can write this in this form. Instead of AB here, just put BA. That's because A and B are both order 2. All right? Okay, so here's your group, G4. Now this, if all elements have, except the unit, have order 2, we did a theorem a while back, theorem 38. It said that group, whatever it is, all of whose elements are order 2, except the unit, is isomorphic to this direct product of two cyclic groups, C2 times C2. Yeah, that's from theorem 38. And the group table of this is this, right? You have two generators, A and B. Okay, and this is the table. Now, we've seen this table before, sort of. I think it was more an exercise. Perhaps we didn't do the exercise. Anyway, you can do it now if you're interested. This table actually is the group table of the symmetry operations of a rectangle, not a square, a rectangle. So if I have here a rectangle, what are the symmetry operations on this rectangle? Well, there's the unit, do nothing, right? There's the rotation by 180 degrees, there's that one, call that R, if you like, rotation. And then there are two reflection type operations. There's the flip about the horizontal axis, so you've got that, okay. That's a third operation. And then there's the flip around the vertical axis. That would be that one. Okay, so that's your fourth symmetry operation. So that group has four elements. Okay. Now, if you fill in the table of with those four operations, you'll get this. Now this is the group table of C2 times C2. It's also the group table of the symmetry operations of a rectangle. Okay, and this group, this rectangular group, if you like, in German is called a Viergruppe. Vier is just German for four. Remember, I speak German. Okay, Gruppe is just German word for group. So four group. Right? And that's where the V comes from, out of a bit of history. Okay, so it's the four group. So this group now, call it V, is isomorphic to C2 by C2. Right? Okay, so we can summarize a little. So if your order of your group is 4, you have two possibilities. It's either cyclic, and that'll be true for any order, any n. Right? You'll always have the cyclic group. So so G4 is of two types. It's either